In our previous videos, we have configured our linear actuator to integrate with our Compact Logix PLC. And then in the last one, we went through the basic sequencing to do the bulk of your pick and place applications that you're using. Now, we've done all this without needing any of the motion instructions in Studio 5000. And that's what I love about using this YRG actuator is you have a single instruction that pretty much does everything. We also do have a whole motion set of instructions up here. There's all these groups through here. And many of you have Kinetix out on your plant floor that you still need to practice some of the instructions with. So what I want to talk through today is how we can use our setup to do some practice of the motion instructions and get familiar with them. All right, now there is already a video in this chapter that we actually convert our whole Kinetix series to operate all of this. So you'll want to check it out. But for the most part, the instructions that I see in most of your programs are the MSO, servo on, MSF, servo off, the MAM, motion axis move, the MAS, motion axis stop, and the MRP, motion axis refined position. So we're going to talk through how we can make a program work with just those 5 instructions. And so we are not going to work in the sequence one that we did last time. Let's go ahead and go to our recents and let's open that LMC program up that we just did our basic configuration with previously. And to recap in it, we have our Ethernet module configured for our linear actuator. We have our add-on instruction, the YAMTOS AOI. And in our main routine, we have our exercise that we did to learn about the add-on instruction. So same as last one, I should have had you do this in a routine. So let's right-click main program, add new routine. And we're going to call this our YRG AOI. And just open your main routine back up. Let's select all the rungs in our main routine and we'll just cut them out. So we're looking at a blank main routine. And then we'll go over here and paste them in. And all we've done is made a little bit of folder organization so we can organize our code. And then we'll go ahead and bring down a JSR, which is on the Program Control tab. Or you can simply highlight the rung and type JSR, press the Enter key, hit your drop down, and grab that YRG AOI. So that gets that part done. And now let's right-click main program, add new routine, and I'm going to call this my Kinetix. And same thing, let's go over here and let's right click and let's copy our JSR rung, paste it, and we'll put Kinetix in for that one. So now we have 2 separate rungs just to organize our code. And let's start talking through some of the instructions up on our motion categories. So if we hit the motion state category, and actually, I didn't mention the motion axis fault reset, but we should do that one. So the ones I really see, in fact, let's just go ahead and drag these down. Let's go ahead and bring some new rungs in. I see you use the MSO, the MSF, and don't get me wrong, I've ran into these in your programs, but the next one on that one is the motion axis fault reset. So that turns our servo on, turns our servo off, resets our servo when it's faulted. And then on the motion move instructions, we use the motion axis stop. I should have thought of this one too. The motion axis jog, the motion axis move. And in our video that we did the full conversion, we are using the motion axis gear. That got kind of in the weeds, but it's there. And then the MRP, motion redefined position. So bring one more rung down. And MRP. And these instructions right here are the ones that I think most of you want to practice on. Now, we will not be able to use some of these instructions, but that doesn't mean we can't learn about them. So the first thing it needs is an axis. And if we right-click on our ungroup axes and new axis, notice All of these are grayed out if you're using a non-motion related controller. And we're using a 1769 L16ER BB1B. And our only option is an Axis Virtual. But we can learn a lot with it. So we're going to make an Axis Virtual, and we're going to call this our linear axis. And then this is an ungrouped axis right now. Let's say we wanted to put it in a group. Right-click your motion groups, new group, and I'm just going to call this my axis group. And now to bring this in, all we do is click linear axis and we drop it up there. So now we have a group with a single axis, and you could add as many virtual axes as you want, but that'll get us through this. Now I should be able to go over here, and I should be able to hit my drop down and grab that linear axis. But notice it's not here. So it's not going to be there on the MSO. If we drop the MSF down, it's not going to be there on that. Now the motion axis fault reset, notice it is there. So depending on which instructions you're trying to learn about, you may or may not be able to do it with this virtual axis, but it can do the reset. It can do the stop instruction. It can do the jog instruction. It can do the move instruction. And it can do the refine position instruction. So the first two are obstacles, but they're not that bad. And so if we right-click the MSO and we go to instruction help, and if we scroll down a little bit, then we see the mnemonic and description here. We have the EN and the DN and the error. And those are the three that we really need to look at. So the EN is set when the rung makes a false to true transition and remains set until the servo message transaction is complete and the rung goes false. Now, arguably, we can take that and mean that the instructions preceding the MSO are true. Now, the done bit, pay attention here. It is set when the servo axis has been successfully enabled and the servo active status bits have been set. Notice it never says that it turns off. So in this case, the first time we get a done and it stays as a done after that. And the error indicate that the instruction detected errors such as you specify an unconfigured axis. Now, since we're doing some simulation to learn about stuff, this one could never happen. And I don't see you use your error bit very often in your MSO or MSFs. So for the MSO, we're going to focus on these two bits. So let's go back over to our program. And while we can't select an axis, we can select a motion control. So I'm going to call this my linear MSO. And then after we type words, we right click them, new, and create. Okay, so now we're going to just add a bit over here. So now on the left side, let's go over to our bits category and let's add a go look for a one. And we're going to call this our servo. Oh, I already have a servo on. So let's call this our Kinetix on. Kinetix. And so if the Kinetix on is a 1, then our enable will be a 1. And all we got to do to do that is bring down an output energize. And then we want the linear MSO, and then open up that arrow on it, and we'll get the EN. And that takes care of the enable. Now the done, really, it writes a 1 the first time and it's done. It never does anything else. So let's bring a branch in. And this time, let's bring down a latch instruction because it'll go right a 1. If nothing else writes to it, it'll stay a 1. And this time we want the MSO DN. So that takes care of our MSO instruction. Now let's just delete that out. And then let's right-click Kinetix on, create it. And we have that instruction done. Next, we have the MSF. So let's right-click the MSF and go to its instruction help. And if we look down on it, it says the EN is set when the rung makes a false to true transition and remains until the transaction is completed and the rung goes false. Or simply, the instructions preceding the MSF are true. The done is set when the axis servo action is successfully disabled and the drive, enable, and servo active status bits have been cleared. Now, since we're doing a virtual one, what's going to happen immediately? So this is the same thing. It's going to write a 1 the first time, and then it's going to stay a 1. And I never see your error bit really used in this, and we really can't get an error bit with an unconfigured axis in our case. So we're going to do the exact same thing that we did up here. So let's bring down and go look for 1. And let's call this our Kinetix off. And let's right click it, new, create. And then let's bring down an output energize. And we'll go ahead and drag our branch down because we're doing the exact same thing we did up here. Drag over it and drag a latch down. And then, well, I mean, arguably, yeah. Well, first we need a tag. So let's call this one our linear MSF. And now for consistency, I did call this Kinetix. I should do that all the way through. And it's a good exercise. Now, as we're building out our programs, we realize, oh, I should have done better on my name, and we'll just right click it. Let's edit its properties. And yeah, let's call this our Kinetix MSO. And then let's call this our Kinetix MSF. And so now we can right click it, new, create, and let's grab the Kinetix MSF. And we want the EN bit. And then here we'll grab the Kinetix MSF, and we want the DN. And arguably that takes care of an MSF. So now we can delete that out. All right, next we have an MAFR. Now the rest of these, we had the option to use the instruction, and we want to fully utilize this. So let's go ahead and just create Kinetix MAFR. And right click it, new, create, and then our MAS, let's do Kinetix MAS. And right click, new, create, and then we have the jog, so Kinetix MAJ. And we'll right click it, new, create. And we have the Kinetix MAM, so Kinetix MAM. Right click, new, create. And finally, we have the MRP. So Kinetix MRP. And right click, new, create. And in front of each one of those, we're going to go ahead and just bring down and go look for 1. And so this will be, for now at least, the Kinetix stop. And right click, new, create. And just keep going down through this. So I'm going to call this my jog, my move. No, just keep doing it. It's a little dull, but. And then we're going to do the same thing here. So we'll do Kinetix. Oh, this one actually will be interesting. In this case, we need Kinetix jog, and then we need, in our case, we're going to jog up for our actuator. So right click it, new, create. And then we also need a jog down, which we're going to think a little about. So let's just copy that instruction and paste it here. And we'll make that one jog down. And we'll right click, new, create. And then we have a move. So we'll call this our Kinetix move. And right click, new, create. And finally, we have our Kinetix refined position. And I'm just going to call that my Kinetix origin. That way, that's a lot of words. Origin. And right click, new, and create. Okay, so now let's start filling some of this in. So, oops, I didn't put anything in front of the reset. So we'll go ahead and put a look for 1 in front of it and call it Kinetix reset. And right click, new, create. Okay, so notice right off the bat, our reset actually works. Now, we've got to do some stuff in our YRG to actually make it work behind the scenes. And on it, if we go right click, instruction help, and we go down, we're going to be looking for the EN here because really we want to reset our servo whenever the EN is a 1. So we can do a go look for 1 on Kinetix motion axis fault reset .en. So we go over here and we find our reset, which was rung 9, and currently we're using the red button. Then we'll go ahead and bring down, well, let's see here. If we're making this exactly like it was before, we should make the red button be our reset instruction. So let's right click. Yes, we should. So we're going to take that red button. In fact, let's just copy the tag. And in place of our Kinetix reset, we're going to paste you right there. That way, we should make this function exactly as it did before. And so now this will be our Kinetix motion axis fault reset, MAFR, and we want the EN. So that takes care of that one. Okay, next we have the motion axis stop command. And the biggest thing that we have to work with the stop command with is this jog, really. Because right now, if you do a jog on a Kinetix, it jogs until you tell it to stop. Whereas on ours, simply you hit the jog button, it moves, and you let off of it and it stops. So this is always a little bit of a stumbling block in that. So really, we want to stop if we're not jogging up and we're not jogging down. Now, similarly, we just realized, oh yeah, that was the red button. Let's go figure out how we were jogging before. So here we had jog forward was our green button and jog reverse was our yellow button. So we should grab those and copy them. And then instead of jog up, that should be our green button. And jog down should be our yellow button. So that gets us jogging. We still got a little bit of tweaking in here to do, but we want to do a stop whenever we are not jogging. Now we could do a go look for a 1 for this one, or we could do a go look for a 1 for this one, but a much cleaner way to do it, if we go ahead and right click the MAJ and go to instruction help, we look down here at the EN, then it says the EN stays set until the process is complete and the rung goes false. So really, the moment you let off of either of those buttons, the EN will go to a 0. And in that case, we want to stop. And in that case, we want to stop our jog whenever this isn't enabled. So let's bring a go look for a 0 down in place of that. And we're going to look at the MAJ dot EN. And let's just delete the Kinetix stop out. Okay, so that kind of is our jog lingo. Okay, now we have a stop type. And also notice you have an arrow here. If you don't pay attention to this, in fact, let me not pay attention to this. As we have a drop down here, what type of stop do we want to do? Where really we are just stopping a jog here. So I'm going to put a jog stop. Notice this rung did not go green, or our red X didn't go away. That's because this right here. Open that up and you're going to see we have some options. So do we want to change the decel? Well, no, I don't want to change my decel, but you could. So I can just throw anything in the decel rate since I'm not changing it. And then we can throw anything in the units because we're not changing it. And then it says change decel jerk. Nope, not changing it. And since I'm not changing it, I can just throw anything into the decel jerk and into the decel units. So honestly, I don't see very often that this is changed in a program, but you have to do something there. All right, so that gets that one going. All right, now then the jog is a little trickier because we have this direction and it needs a 0 or a 1 there. We're going to need a Kinetix jog direction. And then we will right click new and create. And so if we press our green button, we want it to jog one direction. So right in front of this, what we're going to do is we're going to go to the move logical and we are going to bring down an MOV instruction, or in 36 it's now an MOVE, and we are going to move a value of 1. Actually, I don't remember which way's forward and which way's reverse. Let's right-click at the MAJ, go to Help, and Direction. Forward is 0, reverse is 1. So the green button does jog it forward, so we want a 0 there into that jog direction, and we want to copy that, because if we are jogging reverse, we want a value of 1 to tell it to go the reverse direction. And then we have a speed. I'm going to make the speed 100, and we're going to call that our percent of maximum. And we still have that hidden thing down here. So we have our accelerate, and I'm going to put that at 100, and we're going to call it percent of maximum. We have a decelerate. I'm going to put it 100, and we'll call that percent of maximum. Then we have a profile. We could do a trapezoidal, or we could do an S-curve. I'm going to select an S-curve. We have accel jerk. I'm going to put that at 100. And we have a decel jerk. I'm going to put it 100. And the jerk units, I'm going to put at percent of maximum. And all right, we have a merge. We're not going to do a merge. That would be if we're doing some type of blending. We're not doing disable. Now, since it's disabled, this doesn't matter, but you still have to put something here. So merge speed is 0. And then we have a lock position. Let's go look at the lock position and the lock direction and make sure we understand what they're doing. We'll go back over here. And if we look down at the lock position, it says position on the master axis where the slave should start following the master. Now, we're not actually doing any master slave or any type of following, so it doesn't matter. Nor does the lock direction. So lock position, I'm just going to stick a 0 there. Lock direction, I'm just going to put a 0 there. And okay, that will get us with a basic MAJ jog instruction. So the next thing we have is our move instruction. And so here's where the Kinetix is a little bit different. It can get a little clunky when you're actually doing moves, because it only moves every time that this is executed. Whereas the YRG linear actuator, or the AOI, anytime that this value here changes, it changes. So if I put 100 here, it just moves to 100 millimeters. Over here, it's a little different. We're going to have to do a little bit of work right here. But okay, move type, that's the first thing here. So let's go ahead and right-click our IMAM, and let's go to instruction help, and let's go down and look at the move type. And for the most part, you'll either use move, absolute, or incremental. Or if you have a rotary application, it could be shortest path. But we're going to do an absolute. So we'll make that 0. And then we have a position. Where do we want to move to? Now, I could use the same move absolute position that we have here, but I want it as realistic as possible. So we're going to put Kinetix commanded position. And we'll right-click it, new, and create. Oh, that's interesting. It defaults to a dent, but arguably you could have a decimal in it. Ah, that's kind of weird. It even says there it should be a real tag. So I am going to override this one. I'm just going to, instead of a dent here, we're going to put a real in and create. Okay, then we have a speed, and I'm just going to make this 100, and our speed units will be percent. Okay, notice we still have a red X, and that's because this little hidden arrow here, we need to open it up. And so our accelerate, I'm going to make 100, and our accel units are going to be percent of maximum, and our decelerate, I'll make 100, and our decel units will be percent of maximum. And then we have a profile, and we're going to select an S-curve, and accel jerk, I'm going to make 100, our decel jerk will be 100, and the units will be percent of maximum. And we have a merge. We're not doing a merge, so I'll disable it, but we still have to throw something in these, so 0. We're not doing any following, so this lock position can also be 0. The lock direction can be 0. Okay, and then we have an event distance and a calculated data. And if we go over to our motion axis move instruction, and we look down here, the event distance, the position on a move measured from the end of the move. And we may play with that later, but honestly, I never see this in any of your programs. And same with the master distance. I don't see that in any of the programs. So let's go ahead and just put a 0 there and a 0 there. And that'll get our basic move instruction working. Okay, and then our Kinetix origin, we need an origin type. When we hit a drop down, we're going to do an absolute. And then our position select, we want to refine the actual position. And then we have the position. And I am actually going to make a tag for this because I already know that we're going to have to do a little bit of work here. So I'm going to put Kinetix position refine. Oh, I'm sorry, not refine, redefine. There we go. And so we'll right click it, new, and yeah, that's kind of interesting. I would have thought that one would have been a real also. Let's right click this, go to instruction help. And if we look at the, it does say, sometimes you got to keep an eye on those. This right here, I want to make a real number. Because if we wanted to refine the position to 150.5, that will not work with a double integer. So go ahead and hit create on that. Okay, now let's backfill and see what we got to do to make ours work. So first, we need to enable our survey. And we're going to do that with this MSO.en bit. So right click and let's go ahead and copy that tag. I'm going to go over here and let's find our servo on. And so our servo on, we've actually never really got out of the program. So all we're going to do is we're going to paste that in. So whenever we get the Kinetix MSO, our servo will be on. And just going back up, we're not going to need the EN phaser. We're not going to need the mode select. We're not going to need to do anything on the safety interlock. Okay, now we do have an origin. We need to do something on it. And so we will want to origin it. Now this will get really tricky here. Is we have this MRP, but we have a Kinetix origin. We're going to need a second MRP. I can tell you already, but I'll let us talk through why that ends up being. So for this one, we're going to use that EN bit again, because really, if the instructions proceeding of this are true, we want to go origin our servo. So let's go ahead and just take the Kinetix MRP and copy it. And we'll go over here to what we were using our blue button for and origin it. Now, before we're using the blue button to origin it, so we should use the blue button again to origin it. So I'm actually going to paste our new right at the end, and we'll copy out that. Actually, I'll cut it. And we want the MRP.en. So that'll get our origin going. And then we want to origin it when you press the blue button. So I'll paste that right back in. So that'll get that going. All right, now we have the auto mode. Now, we want to do auto mode really whenever our motion axis move is enabled. That's when we want to be in auto mode. So we're going to put Kinetix MAM. Next, we have the auto mode. And really, we want, whenever we're working with this MAM, that's when we want the auto mode. So let's go to instruction help on the MAM, and let's look at a few of the bits in this, because arguably we could use the EN bit, but there is a little hitch here, is the EN will be true. Oops, let me get down to the bits. All right, the axis is moving to the in position. When that's happening, we have the in process bit. So I'm going to say that when the in process bit is on or we're enabled, then we want to be in auto. So we'll go over here and we're going to get the Kinetix MAM, copy, and then over here, we are going to take switch 1 out. We're going to need switch 1 in a second though. So while it's in my clipboard, I'm going to paste it and we'll just take switch 1 out, Control X. And we'll need the MAM.enable. And then let's go over here. We're going to think a little on this one still, but I want that switch 1 before I forget it. I want it right here. And then we'll go back over here and we need a branch around this one. That way we're in auto, we're in auto mode whenever we're enabled or We're in process. That should get that. Okay, next we have the jog forward. And I gotta say, the jog forward was a little rougher because, well, let's go look at our tags here. What we really want to know is this direction tag. Whoops, but I don't believe it's in here. So let's monitor Kinetix MAJ, open it up, and let's see if the direction tag is actually in here. Okay, and it is not. And I would really love for it to be. And I wonder if it could be in the status tag. So let's just take a few moments to see if we can figure it out to make it as realistic as possible. As let's right-click the MAJ and go to instruction help. And I'm going to control F for direction. See, this is where we're telling it a direction. We could use that, but I would love for there to be, oh, here it is. No, let's see. Is this it? Oh, these are extended error codes. That is not what we want because we don't want to do it when it has an error. Jog lock status. MAJ is locked to master when it's true. Master driven mode. Okay, that will not work. Okay, I really hate that. I really would hope that there would be a direction in there. But all right, so we are going to have to fudge a little bit on this one. Is we are going to need to look at this Kinetix jog direction. It's the only thing that's coming to mind right now. So really, if we are enabled, we may look at this after it's actually in the program. So if our MAJ is enabled and our direction is 0, then we will jog. So let's go ahead and copy the MAJ and we'll go over here. And so it was the green button. We're going to make that MAJ.EN. And then we want an EQU equals on our compare tab, or now it's called an EQ if you're in version 36. So if our Kinetix jog direction equals 0, we're going to jog forward. And if it equals 1, we will jog reverse. And then we go back over here. Okay, I wish we could refine this a little more. Maybe we can. We'll see. That gets that going. Okay, we will not be using the manual step, so it's fine. We have the motion axis fault reset. It's taken care of. This one will be perfectly fine. Okay, now we have our position and speed. That's the last things that I think we really have to work with here. And really, that's where we're at. We're at our motion axis move. And so as switch 1, okay, so here's where it gets a little tricky working with the motion axis move, because you'd really wish you could just enter a position that would go there. But we have to see a position change and then do some stuff. And so first, how we're going to make this piece work is we have, if we right-click our MAM, if we right-click the Kinetix MAM and we monitor it, then when we open it up, then what I would really like to see here is that commanded speed and that commanded position, but at least right now it's not jumping out. Maybe we can refine that a little more. But what we're going to do is we're going to grab the commanded position, and actually we made the speed fixed at 100. So let's just stick with that for now. That way we can get this in and see what all we can do. As we're going to need to split these up. Yeah, let's bring a new rung down, because for now we are making our absolute speed 100. So I am going to drop that down and just put 100 into our absolute speed and change this to an MOV instruction. And we can take that out now. And down here though, this will be an MOV instruction as well. And that will be our destination now. And we are going to move the Kinetix commanded position to that, but we only want to do it when the Kinetix MAM is enabled. So Kinetix MAM enable, we'll bring on go look for a 1 down, and Kinetix MAM dot EN. So that's when we want to actually move that into there. All right, now the last little hitch we have, just at least to get us programmed here, is there's no easy way to make this change. So we are going to leave this just like this for now, and then we can talk through some other things. So let's go ahead and download this and see what it does. So communications, who active? And if you need any help downloading your program or we went too fast through any of that, then look down in the description. There's a link to this whole course that'll walk you through all of it. And go ahead and hit that subscribe button. We put out at least one video every week. And go ahead and put your trainer back into run mode. And all right, let's see what we have here. So the first thing we need to do is enable our survey. Well, I was getting ready to say I see a little bit of issue, but this really is how you do a Kinetix one. Let's go see just what happens here. So let's go look first at our add-on instruction. It says everything is good. And so the first thing we would want it to do is the servos to turn on, and that's right here. So we go over here and we right click our Kinetix on, toggle bit. Okay. It does appear that it worked. Our servo is on. And if we go down here and look, it does say it's on with no errors. So that tells us that we're on. So the next thing we would hope to do is jog. And so we have our green button should jog up and our yellow button should jog down. And when I press the yellow button, it does go down. Now I press the green button, it goes up. All right, now let's look that in our program, see exactly what's happening. So I press my yellow button and it is going down. Ooh, it says an error there though. I want to see why we got an error on this, even though, because yeah, obviously we're faking this code out. But let's go figure out what our error is. Actually, I already know what our error is, but let's go look at it. And let's go ahead and right click our Kinetix MAJ and let's monitor it and hit our arrow by it. And if we look inside of it, we have an error of 1. That is a Boolean. Either we're in error or we're not. But then we have an error code down here of 51. So let's go back to the Kinetix, right click the MAJ, and let's go to instruction help. And if we go down, we're going to find an error section. And it says error 54, extended error codes. Where is error 54? Oh, yeah, that's right. We had to go to our motion error codes. Then we go down and we find error 54. And for error 54, it says you cannot start motion if the maximum deceleration for an axis is 0. And yeah, we went through that whole thing. It does work, but I forgot to actually put any parameters into our linear axis over here. So we go over to the program that we actually used when we converted our whole Kinetix series into this linear actuator, and we open up our left axis. We already figured out that dynamic. So let's just go through all these. So the motion planner, we left everything blank. The units, we left everything blank. Conversion, we left everything at default. Actually, let's double check that. I'm sitting here saying this, but it wouldn't hurt to double check. So yeah, our motion group, motion planner, units the same, conversion 8,000, homing position is 0. Go over here, homing position is 0. So yeah, really we have this dynamics tab that we figured all this out with. And so what we're going to do is we get a dynamics. It's not going to let us actually enter anything in, but you have the manual adjust button here. And when I click it, these we can change. So we're going to make them exactly the same as this. So 600, 2760 on those two, 100 on those two. So I'll enter 600, 2760, 2760, 100, 100. And we click OK. And click OK. And so a little bit, because I did just throw these numbers at you. And the other lesson, we figured out that this was the dynamics of our actuator. Now, if we press the yellow button, it jogs down and we don't get an error. We press the green button, it jogs up and we don't get an error. So that does get our jog almost working. We'll come back to it though, because I'm going to show you there's an error with it that we're going to have to work through. So the other is our automatic operation. So we're hoping to switch which one. Right now it is a commanded position of 0. Let's toggle the Kinetix move off. And then let's put a commanded position of 200, which would be about 2/3 up our actuator. And now when I toggle the Kinetix move, it zooms up to 200 millimeters. And because of this, if we go looking, at our actual position in our linear axis, let's just right click it and let's monitor it, and we open it up. Then if we go down and find its actual position, also you notice these are grouped typically. There is a box right here. If you check that box, it actually sorts them. So our actual position is 200. And if we go over here and we make our commanded 100, oops, we have an error there. I didn't think about that. Okay, so we're not accurately doing it. Now, just so you see what I saw, it moved when I did that. A Kinetix will not move when you do that. It should, but it doesn't. But if we look here at our commanded position, notice it says 200, but we did move to that 100 position. And the issue is, I told you over here on the YRG, if we were enabled or we were in process, that it should be in auto mode. That's wrong. This should just be the in process bit. So let's start a rung edit there and take that enable out and finalize it. And now if we go over here and we put a commanded position of 300 in, then when I hit the enter key, it doesn't move because we need to toggle our Kinetix move on and off. So it has to see a false on that, and then it has to see it go true. And the moment we do this, it'll run up to 300 millimeters. And if we go look at our actual position, then we're at 300 millimeters here. Now, this is a simulation. We're not perfectly doing this, but just so we can see what the two look like, let's right-click our linear axis actual position, and let's trend it. So that gets me a graph looking at it. And then let's right-click the black area, go to Chart Properties, and go to the Pins tab, and let's hit Add Configure. And let's go grab that linear AOI actual position, because this is the actual position of our linear actuator. We'll add it, and boy, do not hit the OK button here. I wish if you add something in here, they would gray this button out. But after time I hit this, if you do, it doesn't actually add it. You have to hit the add button. Then you can click the OK button. And then let's go to our x-axis because the default is 2 seconds. It's going to zoom by before I can even get any words out of my mouth. Let's go ahead and put it at 30 seconds. And then notice this line is not moving. So in a nice gray on gray right here, we have run that we have to hit to get this actually doing something. Okay, so they're both at 300 millimeters. And we go over here to our Kinetix. And I'm going to put 100 millimeter. I'm going to put 0 in. There. And we go over to trend. Neither one of them move because it has to see a false to true transition. And so we're going to toggle that bit off. And we're going to toggle that bit back on. And if we notice, oh, okay, now we do have a little bit of a difference here. And the issue is, you know, even when I was saying it, it's like I felt like the words coming out of my mouth were wrong. You see, well, here, actually, this is a really good learning opportunity, though. Let me go ahead and just stop that. You see this nice curve here? This is what we call an S-curve. And that is not what we're actually using. We are using a trapezoidal move, which means that it immediately goes to the position. So we go over here to our motion axis move, and we hit our arrow there under our hidden things. I selected S-curve right here, and I think I did the same thing. Did I do the same thing on our jog? I did. That was a total mistake on my part. Is I opened up that arrow. Instead of an S-curve, we want a trapezoidal move on our jog. We want a trapezoidal move on our MAM. I feel like I did that somewhere else, but it's not coming to me where. Because let's see, a motion axis stop, it doesn't have it. Well, maybe that was only 2 places. Okay, so we'll finalize that. And now we're going to put our commanded position at 300, which will run it back up the other way. We need to get our trend back running. They're both flatlined at 0. And now we will toggle this off, toggle it back on, and it moves. And there's yeah, there you go. That didn't turn into a perfect exercise of the previous one is what an S curve looks like. This is what a trapezoidal looks like. But you can see those are falling really tightly. So the auto mode will work perfectly. The manual or jog mode does not work perfectly because with the virtual axis, there are no limits. You can jog to infinity and beyond. We have limits here. We can only get to 300 millimeters. We can only get to 0 millimeters. So I'm at 300 right now. I'm going to switch one. That's going to let us use the green button to jog up. And if we go and look at our actual position, let's see, where's the best place to do that? We'll go back to Kinetix here. Actually, no, we have a trend on it. Right here, we go to controller tags. Our actual position is 300, but when I hit the green button, we can jog beyond our axis here. And if we go into our virtual axis, there is no place to actually set any limits on how far this thing can go. So what we need to do is we need to make some artificial limits. And that's where all of a sudden you saw me I kind of hiccuped. I was starting to do something really complicated here, but this is our home. We need another motion for refine to really fix this jog issue. And so we're going to bring another rung down and we're going to do the same MRP instruction. So we'll go over to our motion axis move instructions. And we want to grab that we're going to there it is, motion move. Bring another one down. And we're going to do the same axis as before, our linear axis. And this is going to be our Kinetix jog refine. And we'll right click it and new and create. And then the refine type is going to be our absolute position. Our position select will be the actual position. That's what we're actually refining. And then for our position, let's think through this a little bit. So first of all, we have that we're jogging. There's our first thing. And actually here it is. We're jogging in the direction we're jogging. Actually, no, we're jogging. Let me try to think through this. Is there a way I could fix this without a lot of hitch? Yeah, really, we have two limits. So let's bring an equals down from our compare. And we're going to look at our linear axis dot actual position is greater than 300. I put equal, but no, that needs to be a greater than instruction. So if we hit our drop down here, we can see all our compares. I want to know if it's greater than 300. And if it is greater than 300, then we want to move. So we'll go to the move logical tab. We want to move a value of 300 into the Kinetix jog position. Position, I'm going to put MRP in there just so we happily know what it is. And new. And that will be, actually, I'm surprised this is defaulting to a dent, but it is. So we're going to change that to a real just in case we wanted to refine it to 300.5 or something. And then we want to do that right there. So similarly, if we are less than, in fact, let's just copy these two. And if we are less than 0, we want to move a source of 0 into that refined position and refine it. Now, one other thing, and I can't decide if this is hitch or not, we only want to do this when we're jogging. So really we have a jog. In fact, arguably this should be on this rung, but yeah, we only want to do this when this MAJ is enabled. So Kinetix MAJ, I'm going to stick that in front of it. And honestly, this is not going to do much for us. more than anything, this is just for our sanity of why in the world did we do this later on? So Kinetix, MAJ, and we want the EN. It's only doing it, it's only fixing it one time. If you continue to hold your finger on the button, then that becomes an issue. So here's a neat little trick. We want to do this really whenever this one's not enabled. So I'm going to start a rung at it here because this will become a 1 when we do it. If we put a go look for a 0 right here for this jog, refine, redefine, dot, en, it'll do it as long as it's not enabled. So let's finalize that. You'll watch right here. In fact, you know something, we are doing this just for the jog. So I'm going to leave that jog in there. And now if we try to jog up and I hold the button, whoops, you can't see anything. I need to go back over to my watch window. We're at 366. That gets us a 300. Ooh, okay, we still have a little bit of issue because when we let off of it, we have our decelerization rate. And that has to do with that MAS. So, you know, really these limits, in fact, I'm just sitting here thinking, I don't know why I even put that this had to do with jog. This has to do with physical limits that we're trying to put on a virtual axis. Yeah, so really, this is not Kinetix jog redefined. This, in fact, let's rename this. This is really Kinetix physical limits, MRP. And then, yeah, this is, yeah, and that's fine. This is to fix our physical limits. So now we're at 300 and it shows 300 and I hold my finger on the button. We see it bouncing a little bit. That has to do with scan time a little bit. But there you go. That fixes that. All right, now I'm going to jog it down to 0. All right, we will see it bounce a little, but yeah, that's pretty much fixing that. And now we should be able, in fact, let's look, what is our commanded position right now? Oh, that's right. With the Kinetix, you do still have to do this little toggle dance anyway. Well, no, so we're waiting on switch 1 right now. I'm going to make my commanded position 150, and it is waiting on switch 1. So I switch 1, and it runs up to 150. So there you go. That is how, and I know that, boy, if you're here still, this is what, oh, nearly an hour-long video. But I hope you are, you know, realizing a few things. One, now you can practice your Kinetix instructions with a non-motion rated PLC. And that's a game changer right there for those of us learning. But if you're in the planning phase of a project and you're at this phase that you're looking at me and thinking, all right, great, I know how to learn about the Kinetix so I can implement it. Back up and think, are you sure you actually need a Kinetix drive? Because we could build a Kinetix trainer. Honestly, we have built them before. You don't see it for sale on our website because really, I think this is a smoother setup right here. So if you're doing a basic pick and place, grab a part here, move it over here, position this, then there are a lot of other options out there. Now, if we are doing a gearing application, or any type of following application, or any type of cam application, that's where the Kinetix comes in handy. All right, if you are to this point, then thank you very much. You have a lot of patience with me. And this playlist right here is the Kinetix series that we actually go through what all these instructions do. And we actually build this all the way out to a following application. So click here to follow me over there.